Okay, today I'm going to talk about how to write a password cracker. And we need to start with some um, basic maths. So I'm just going to just put a couple of some notes in my code here to remind you of your school maths. So if you go right back to the beginning, uh, units, tens and hundreds, probably one of the first things we all learn about in school. So if you just remember that the number 123 is made up of 3 ones, 2 tens, and 100, and these columns are actually powers of 10. So 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 2 is 100, and that's where these numbers come from in multiply. And obviously we're very familiar with this system. So what you can do is you can have any base. That's called base 10 because it's based on powers of 10. But imagine if you had a number system that was based on letters of the alphabet. So there's 26 letters in the alphabet. So you've got 26 different permutations. So that means your number system would be base 26. So let's see how that looks. So imagine you wrote a number down, you wrote X, Y, Z down, and you wanted to convert that back to a decimal number. So X, Y, Z, so the Z is the 26th sorry, no, it's the 25th. 25th in the if you give it a number value of 25, A is 0 and Z is 25. And these column values are 26 to the power 0, 26 to the power 1, which is 26, and 26 to the power 2, which is 676. So just based on their positions in this list, Z is 25, Y is 24, and X is 23. So to calculate the actual values, it's 25 times 1, 24 times 26, and 23 times 676, which comes to 16196. So that's pretty straightforward. Now, if you wanted to convert, if you wanted to do the reverse operation, then this is how you do it. It's using the same principle, but you've just got to know you have to use this division and remainder operation. So you iteratively divide by 26, then you take this number, this is called the divisor, this is called the quotient, and this is the remainder. And you take, for each time you iterate through the number, you take the quotient and you use that as the divisor in the next line, and you come up with, and the remainder gives you the actual letter. So in this case, Z, Y, and X. So that's it. If we can replicate this process, what you can do is you could, yeah, just to give you the example of ZZZ. So ZZZ, I'll just paste that here like that. So the number ZZZ is the highest number, and using the same calculations, you come up with this upper bound. So if you can iterate, if you're trying to crack a password, you could iterate from 0, which would be AAA, everything's got a value of 0, to 17575. If you go through every number in that sequence and convert that number to your password string, so that'd be your 3-character uppercase alphabetic, you can use that to try and guess what your password is. And in theory, that would mean you could check every permutation of the password until you got the right one. Obviously, in real life, your security would kick in, and so this you could regard this as a good a security check to make sure that your password verification process doesn't allow you to batter it with this brute force password cracker. Any commercial password password system would lock after a given number of attempts, usually 3 attempts, or at least timeout. Interestingly, what some systems do is they will progressively increase the timeout that you can try to make an attempt at a new password. So rather than just locking, they just make larger and larger time periods for which you have to wait. Which makes this approach totally impossible to use to crack a password, because ultimately it'll go up to like a day. So you get one chance every day. And if you think of the number of permutations in a real life password, then that just means it's unfeasible. So this is it's like a good check for a password acceptance algorithm. Right, so let's start. So I'm going to write in very high level terms to start with. I'm going to start with the third character. See if I can guess the third character using the algorithm I've just got there on the screen. So this is to work out what password corresponds to this number 16197. Now we know it's XYZ, but this is just an example. So to work that out, we'll need a result to put the quotient and the divisor in. So I'm going to just leave that there, and I'm going to create a class. So a class and a method. So we've got divide by 26, and that's going to divide our divisor. So the result's going to hold our quotient and remainder. The divide by 26 is going to do the divide operation that I've shown just here. And then once we've got that result from the divide by 26, then we're going to get the corresponding character for that result. So that'll be a number from 0 to 25, and we just want to convert that to a capital letter. So result.remainder. Keeps asking me to change this to something, but so I just want to create my own result class here. So I'll just create this static class. Just to hold the quotient and the remainder. So we've got result, and we're going to have an integer quotient, because Java unhelpfully doesn't let you return more than one value. Integer quotient, integer remainder. Oh, I've done it outside the too many. What have I done? Yeah, that's right. So we've got our static class result. So that's that line sorted. Now we need to create a method divide by 26. I'll come back to that one. Let's do the misspelled remainder. Let's do the get char one, because that's the nice simple one. That's literally just come on, create a method. I'll take all the defaults, and all we need to do actually is use this sort of ASCII. So string char equals how do we do this? So if we just do a character toString operation, and we cast the value to a character, so we're passing in this remainder, and we just want to add 65 to it. 65 is the ASCII code for A, capital A. So this will very simply give us the corresponding character is it complaining? Oh, it doesn't like me using char. So yeah, so it's character, returning character, whichever. So yeah, 65 is the ASCII code for capital A. So if that's 0, if the remainder is 0, then this will return a capital A, and if it's a Z, it'll return. If it's a 65 plus 25, it'll return a Z. So that's that bit. Let me just implement this one. So this divide by 26. Okay, I'll take all the defaults. So we know we're going to need a result, so I'm just going to create a new result. And the quotient, so the quotient is equal to the divisor divided by 26. Because it's an integer, it'll just ignore the remainder or the decimal part of the result. And then to get the remainder, we just do the same operation again, except this time we do instead of doing a divide, we do the modulus operation. 26, special percent, and that literally just gives you the remainder, and then return the result. That percent gives you the remainder of a division result, which is exactly what we want. So that's it. So this, so there's our third character 3. So if I just do a quick password, I'll create a password guess variable, just a string, password guess. So this would be one attempt at a guess. And I'll just, for the minute, I'll just say equals char3, like that. Let's just run that, and hopefully we should get a Z. The password guess should be Z. That's the third character of the 3 characters. There we go. Password guess Z. So what I'm going to do now then is just duplicate this block. Obviously in real life you would this would be in a loop, but just to make it nice and clear, I'm going to keep it as 3 separate sections. So the divisor now becomes the result. Oops. The result quotient. And you just check back on those notes there. That's how it works. And the result is divided by 26 divisor, and now we're going to have character 2, which is just get the character from that remainder. Actually, I can delete that and just duplicate that's that second character. Second character, and let's just duplicate that again. And for the third character, exactly the same. So obviously this could work for any character set in any length password. That's character 1. And then the password should be character 1 plus character 2 plus character 3. There we go. There's the code all together. Let's run it and see if it works. So we're hoping for our password guess. We're hoping that we've taken this number and we've converted it to XYZ, and then we could use that, test it against our real password, our actual password. This is our password guess. There we go. Password guess XYZ. So yeah, that's it. Hopefully this has been of some use, and thanks for watching. Cheers.